trigonometry. So this is introduction to trigonometry. So basically, what is trigonometry? So trigonometry is the study of triangles. So in particular, in grade 10, we're going to be looking at how we use the right-angled triangle to solve problems. So first of all, we are going to do some introduction, right? So the background knowledge that you guys need to have when we do trigonometry is that you need to have some knowledge of triangles, general triangles, that is number one, and in specific the right angled triangle. And then you also need to be aware of your Pythagoras theorem and also the notations that are used when you are dealing with triangles. How do you write a side, represent a side in short, and an angle? Okay, so let's go on with that. All right, so the notations that we use when we are dealing with triangles is the one that we want to deal with. I know that we are from grade 9, we've been doing this. This is just a recap, right? The jump start, you can call it that. So if you are given triangle ABC, so we draw a small triangle and then we say ABC. This is red triangle ABC. And then an A with a cap, or 3 letters with the middle letter with a cap, or a slope sort of a crocodile, mouth open, and then 3 letters. These are all notations for angle A in triangle ABC. Okay, let's hope you remember these, and you need to use them because you cannot always be writing statements and terms. You have to write it in short. So those are the notations. And the side AB, represented by the small letter C, these are both notations for the side AB in triangle ABC. So side BC, and also represented by small letter A, is made by angle A. If angle A is bigger, then the side will also be bigger. And then this little symbol with a box in the corner represents a 90-degree angle, or we say that two lines that are perpendicular to each other. Okay, so you can see here we've got all these terms, these notations that we use, like this one. Again, we said it's red what? Triangle ABC, and then we've got an A with a cap, and then 3 letters with the middle letter with a cap. It represents angle A, and then with the one with the open which I call the crocodile's mouth open, and then 3 letters, this also represents angle A in the same triangle. And then the letters AB, which means this is the line starting from point A ending at point B, and it is represented by small letter C. That depicts that side is made by an angle C, which is a capital letter C. And these are both notations for the side AB. And you can also see that the angle BC, represented by the small letter A because it's made by the angle A, right? If the angle is big, we expect also the side to grow big. If we increase the angle, the side will correspond. Are we together? If it reduces, the side will also correspond. And also now, this is a notation which we use to represent 90-degree angle. Okay, moving on. Now let's look at the triangle. Right now we want to look at in triangle ABC, right? And we want to see, right, so we can see that in this triangle ABC, the angles are depicted by the Greek letters which are inside there. So you can see that angle B is represented by the Greek letter theta, and the angle A is depicted by the Greek letter alpha. So again, we can also label the sides with small letters, like I said before, of the angles opposite to them. So the side BC, we can call it A. The side AB, we can call it C, and the side AC, we can call it small letter b. So we can also identify sides with reference to angles. So starting with the angle C, we can see it's a 90-degree angle. So the 90-degree angle makes the biggest, or yes, the longest side of a triangle, and we call that side hypotenuse. It's always opposite the 90-degree angle in a right-angled triangle. So can you see that? So that is how we can identify the hypotenuse. It's always opposite the 90-degree angle. Okay. Right. Moving on, we can also label the side. If you are given the side B, let's call it theta. Right. So the side B, we can identify the other two sides with reference to the side theta. So when we have got the angle B here, which is equals to theta, right, we can say BC is adjacent to the angle theta, right? So according to that, we can say BC is adjacent to the angle theta, and AC is opposite the angle theta. So we can call, with reference to angle B, we can call side BC the adjacent side, and the side AC the opposite side. So you can see we have named these sides with reference to the angle theta. So what does that mean? So we can now, let's just do some trig ratios given a triangle. So there are 3 trig ratios, right, which we can have. So these trig ratios define the relationship between an angle and 2 sides of a triangle. So these trig ratios are sine, abbreviated sin, and cosine, abbreviated cos, and tangent, abbreviated tan. So having the triangle ABC, right, you will see that in triangle ABC, we can say sine of angle B will be, right, we can write it in different ways. Remember, we can say sine of angle B will be equals to the opposite side all over the hypotenuse. And this will be AC all over AB. And then cos of angle B, which is cos theta, will be equals to the adjacent side all over the hypotenuse, right? And then we can also say tan of angle B, which is tan theta, will be equals to the opposite side all over, or divided by the hypotenuse side, which is AC all over BC, right? Not AC, but it's actually, right, so there we go. Okay, so the cos B will be, which is cos theta, will be equals to adjacent all over hypotenuse, which is equals to BC all over AB. So tan B will be equals to tan theta, which is opposite all over, or divided by the adjacent side. So this will be AC divided by BC. So you can see these are the relationship of the angle and 2 sides given by the trig ratios. Okay, now let's just write down the summary of these trigonometric ratios using a different triangle. We've been using triangle ABC. Now let's look at triangle MNO. So we are going to label the trig ratios in reference to these angles. So we are going to say sine of angle M will be equals to opposite over adjacent, which will be equals to ON all over OM. And then sine of angle O will be equals to opposite over hypotenuse, which is equals to MN all over OM. And then cos of M will be equals to adjacent all over hypotenuse, which is MN all over OM. And then cos angle O will be equals to adjacent over hypotenuse, which is ON all over OM. And then tan of angle M will be equals to opposite all over adjacent, which will be equals to ON all over MN. And tan of angle O will be equals to opposite all over adjacent, which is MN all over ON. So these are the trig ratios. So we can put the trig ratios with reference to these sides, right? This shows the relationship between the angle and 2 sides. So the relationship between angle and angle M and 2 sides ON and OM is that it's going to be sine of angle M will be equal to side ON divided by OM. So if they are numbers, we then find the ratio. Okay, Now let's look how to summarize this. So you can use acronyms for you to remember these trig ratios. We can use SOHCAHTOA or CHASHO-TAO, right? So you see here, when we say SOHCAHTOA, SOH and TOA, right? Those are the acronyms that we can use to remember when we are dealing with the trig ratios. So this is SOHCAHTOA broken down to SOH, CAH, and TOA, TOA. So SOH will be standing for sine of an angle, will be equals to O for opposite, right? And then H for hypotenuse. Can you see that? So SOH in SOHCAHTOA stands for sine of an angle. This applies in a right angled triangle only, right? SOH will be equals to sine of an angle will be equals to opposite all over hypotenuse. And then CAH, which is CAH, stands for cos of an angle will be equals to the adjacent side divided by the hypotenuse side, right? And then TOA, TOA, standing for tan of an angle will be equals to opposite side all over adjacent side. And then CHASHO-TAO is another acronym which you can use. So you use the acronym which works best for you, which you remember fast, good for your memory. So for CHASHO-TAO, we've got CHA and we've got SHO and we've got TAO, right? So CHA will stand for cos of an angle is equals to A for adjacent and H for hypotenuse divided. Can you see that? And then SHO is sine of an angle will be opposite side divided by the hypotenuse side, right? And then TAO will be tan of an angle will be equals to opposite side divided by an adjacent side. Okay, right? So you can see these are the summaries which we can use when we want to remember these trig ratios. Now, if you don't have any problem